From above, you can see that South Korea's PyeongChang region is nestled in a complex and rugged mountain range. Up close, professional athletes and spectators are dotted in the mountain's crevices for the 2018 Winter Olympics. The area has vast vertical drops and an average high of around 40 degrees Fahrenheit in February, making it an ideal location for the Games. As it turns out, the mountain range is also an ideal place for NASA scientists and engineers to study snow.
So we're here on the roof at the radar. All the games will be happening about 5 kilometers away from where the radar site is.
This is Manuel Vega, an engineer that's part of a NASA team at the Winter Olympics, studying how well they can measure snow from the ground and space to better predict snowstorms. NASA is one of 20 agencies from 11 countries working together in a project called ICEPOP, the International Collaborative Experiments for PyeongChang 2018 Olympic and Paralympic Winter Games. Around 70 instruments have been deployed for ICEPOP across PyeongChang's diverse landscape to monitor the characteristics of snow. Factors such as temperature, altitude, and winds affect what types of snow forms and how much water is stored in snow. More than 1/6 of the world's population relies on seasonal snow for water, yet it remains as one of the biggest gaps of knowledge in the water cycle. To understand snow's role in the water cycle, it helps to monitor snowfall patterns around the world. With NASA's Global Precipitation Measurement Mission, or GPM, scientists can see global maps of rain and snow every 30 minutes. But complex terrains with mountains and fast-changing clouds can be difficult to decipher from space. ICEPOP gives scientists an opportunity to use the ground instruments to check that what GPM is seeing from space is close to what they're seeing on the ground. Scientists call this ground validation, which is key to understanding snow on a global scale. Another aspect of understanding snow is predicting when snowstorms occur. NASA is providing ICEPOP with one of 5 real-time research forecast models to experiment with predictions in a real-world setting. NASA's model provides forecasts over 16 different Olympic venues every 6 hours to Olympic officials. And with ground instruments scattered across the region, they can test how accurate the forecasts are.
The most satisfying things is contributing to scientific knowledge.
In short, the science community hopes for what a lot of Olympic athletes want in PyeongChang: precipitation and perfection.